everyone, today I'll be introducing this line following drawing card. Basically, there will be random shapes, and the robot will display the path while following through the lines. For robot construction, you will need one color sensor, or two if you like, two large motors, one EV3 Brain, and one gyro sensor. Next, let's get to know the coding concept. Our goal is to display the path that the robot is currently following. And when we start the code, we will have two tasks running at the same time. One is the line following task, and another one is the calculating task. Next, let me introduce you a function that you will need to use in this project, and also it's in Robot C. So this function is called drawLine, and there are four spots that you have to fill in. It's x1, y1, x2, and y2. And x1 and y1 means the starting position of the dot, or of the line. And x2 and y2 means the ending position. So this is how the line would look like. So for example, you have a draw line 0, 0, 27, 27. The line will start at 0, 0, and it will end at 27, 27. Now, let's talk about line following. This is one of the important tasks. So step 1, we have to check the reflected value of both the line that you taped on the ground and also the floor. Step 2, we have to sum two values and then divide it into 2. So, for example, we have the line value of 8, which approximately is a black line. And floor value, we have a 62, which is a white floor. So we add up these two and divide it into 2. So the value will be 35. Keep this in mind and we'll talk about it in the code section. Next, let's talk about the displaying or calculating task. Step 1, we have to know how many degrees the robot moved. So in the example, the robot moved in a straight line. And we just have to take the left motor degrees plus the right motor degrees, or more like how many degrees the left motor moved and how many degrees the right motor moved, and sum it up and divide it into 2. Let's look at another example. The robot moved like a little bit right. So how we calculate the movement of the robot is still the same. We take how many degrees the right motor moved and how many degrees the left motor moved. We sum it up and divide it into 2. So they are actually the same thing. Now we know how to calculate the movement of the robot. So how do we get the left and the right motor degree, which is how many left and the right motor move? So we can take the current encoder and minus the last time's encoder. So we can get how many degrees the left and the right motor moved. So we can change the equation into delta left plus delta right and divide it into 2. Now we know the movement of the robot, but how do we know how many pixels does the x coordinate and y coordinate move? We will need a little help of the trigonometric function. So we have a 90 degrees angle and also an angle theta. So we can know cosine theta equals delta x divided by movement of the robot, the red line. And sine theta would be delta y divided by the movement of the robot, the red line. So we can have this equation. Delta x would equal cosine theta times the movement. And delta y would be sine theta multiplied by the movement. So this is how we get the x-coordinate and the y-coordinates movement. And this will be the step 2. Now we have the equation. Step 3 is to get the theta. We first see the cosine. There is a braces called radian inside. This is the Robot C function of cosine and sine. How do we get radian? So we have to transfer the degrees into radian. First we get the theta. Theta is 90 degrees minus get 0 degrees. And why? On the chart above, we can see gyro degrees at 0 degrees is facing north. And we can see there is a 90 degrees angle consists of gyro degrees and theta. So this is why 90 degrees minus get gyro degrees currently is now theta. Next, we are going to calculate the radian. So in radian, radius and the arc length are the same things. First, we set an x degree that is going to transfer into radian and set the radius as 1. So we basically just have to calculate the arc length and we'll get the equation which radian equals degrees times 3.14 divided by 180. Now we just have to draw out the line and also put the current values into the last value variables. Now let's get into coding. Okay, so now let's see how I actually coded the code program for the robot. So I used 4 ports, and from line 7 to line 16, these are all variables that I use. So the integer variables means that it's an integer, and the floating point variables are the ones that we have to keep an eye on, because this actually matters a lot on displaying, because these variable actually multiplies pi, which is 3.14, which makes those numbers into a floating point number. And we can see I used 2 tasks right here. So one on line 18 is the line following task, which is used for line following. And on line 27, this task is for the calculating and also the display of the path that the robot went through. So let's see the line following task first. So I have a error value calculated, which is taking the target value and minus the color reflected value that the robot currently detects right now. And this calculates the error value. And then we multiply the error value by a certain number, and I use 0.4, which I think is the best for my robot, which while it's line following, it doesn't wobble that much and it still does the work. But I also have tried 0.9 or like 1, but that makes the robot wobbles a lot, so I suggest you to decrease the number by a little. And then we take the minimum power that we set, and I set it at 20, and I plus the output value, and for the right motor I also minus the output value. So this makes the robot turn to adjust the position of the color sensor. So also adjust the position of the robot while it's following the line. So next we see the calculating part. So first we have to start this task that we just wrote right here, and because this makes it do these both tasks at the same time. And then I drew a line on 8964, and this because the first x and the second x value and the y are all same, so this means that I actually drew a dot instead of an actual line. So why 89 and 64? It is because the EV3 Brain screen consists of pixels, and the x-coordinate length pixel is 178 pixels, while the y length is 128 pixels. So this means 89x and 64y is at the middle of the screen. And then in this while true loop, this is how I calculate like how it is going to display on the screen. So from these first 3 lines, these are all the same as I mentioned in the concept part, but on line 37, this one's a bit special. It's because I actually divided the movement variable by 500. This is because if I don't divide it by 500, the shape will be too big for the screen to display, and all you will see is just a line or a slightly curved line. So I divided it by 500 to make sure that the whole shape is inside the screen. And then we calculate the radian and also the x movement and y movement, and we draw a line from the last x, last y, and then the newer x and y. So at last we have to take the current value into the variable that consists the last value, because in the next loop the current value will become the last times value in the next loop.